Hey everyone, in this video we're going to go over sections 3.2 and 3.3, different measures of variation. Some of the things that we're going to talk about include the range, standard deviation, and variance. And we're going to learn different ways we can graph the data to analyze it. So in this activity, later on, we're going to continue using StatCrunch to find our statistics. So let's consider this data set. So we have a list of receipts from one night at a restaurant. And so this is 10 values of different receipts, right? So imagine you're people who work in the service industry at a restaurant. So over a period of time, you serve different tables and everyone's receipt is different. So that's one of the studies of statistics, right? We want to study variability. And so let's take these 10. So first thing is create a dot plot for the data, then find the mean, median, mode, and the range. So the reason that a dot plot is useful is because it already organizes the data from smallest value to largest value. So I have my horizontal here for the dot plot. And so we got to think about what's the smallest value, what's the largest value, and how do we want to split up our number line. So notice that our smallest value is 38 and our largest value is 56. And so we're gonna, and everything seems to be around 40s. So what I'm gonna do, I don't necessarily wanna go 38 as my lowest value, so I'm gonna go 36. And then I'm gonna go by twos. This is, you can choose however you want. You can go by ones, you can go by fives, but based on that, everything is mostly even. I'm going to go by twos. So I have 36, 38, whoops, that should have been a 38, 40, 42, 44, 46, and so on. I should have made it longer. Okay, 56 and 58. So I went 2 under my lowest and 2 over my highest. And now for the dot plot, we put just dots over each data value. So I'm going to go in order. So 44, order in appearance. So 44, so I don't lose track. 44, then 50. So you just place a dot over each of the data values. 38, 56, 42, 47. I don't have, I went by twos. So I don't have 47, but I know it's between 46 and 48. So I'm just going to put it in the middle there. And then 42 again. So this is where in a dot plot, we just stack them. 39, so same thing is in between 38 and 40. And then 46 and 50 repeats. So notice that I have, this is my dot plot. So 2 values repeat. We could kind of say that it's bell shaped, right? I could draw a very narrow bell curve around this. It's pretty even. All right, so there's our dot plot. Find the mean. How do we find the mean? The mean is the sum of all the data values divided by the number of data values that we have. So in this case, I'm going to sum all of these data values and I'm going to divide by 10. And so that's the mean. The median is the value that's in the middle. So we can find that out. But first, let's continue with the mean. So let's take our calculator and add all these up and see what we get. When we add all these up, I get 454. So when you divide by 10, you get 45.4. So this is the mean, and the notation for the mean is x bar. The median is the value that is in the middle of the data. So now that I have my dot plot here, we can see, okay, so then there are 10 values. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because it's even, the median is the average of the 2 middle ones, right? So when I order it, I have 38, 39, 42, 42, 44, 46, 47, 50, 50, and 56. So 1, 2, 3, 4, 5, and 6. Let's see, 1, 2, 3, 4. Notice that I have 4 on one side and 4 on the other side. So I'm going to take the average of this 2. So the median is going to be 44 plus 46 divided by 2, or I can just look at it, right? What's in the middle of 44 and 46 is going to be 45. So the median is 45. It's not a value in my data set, but that's okay. That's what the median is. So the median is 45, and the mean is 45.4. So we slightly skewed right. The mode is the value that repeats more often. So in this case, we have two modes. So we say this data is bimodal. And the modes are the ones that repeat, 42 and 50. So those are the ones that repeat the most. They repeat the same number of times, so we say that data is bimodal. And the range. Now, what is the range? The range is we take the maximum value and then we subtract the minimum value. So in our case, the range is the maximum value, which is 56, minus the minimum value, which was 38, and so the range is 18. So that is, and now let's keep in mind the units, right? What was this? We are talking about receipts from a restaurant, for a night at a restaurant. So that means that the range, so our lowest value is $38 and our highest value is $56. And then the receipts, then the bills range $18 is the range from the lowest value to the highest value. So the entire rest of the receipts are within $18. So that's what the range is telling us. So that's our maximum data value minus the minimum data value. And so this will be in dollars. So $18 is the range. How spread out is this data, right? The range also helps us tell that. It's like, okay, from the minimum value to the largest value is 18. So that means that the bulk of the data is within $18. But a more precise method of telling variation is the standard deviation. And what this is we want to find the average distance from the mean. And that's what we call the standard deviation. And the notation is S if it's for a sample. If it's for the mean, for the population, then it's the lowercase sigma. So this will be the population standard deviation. So here's the notation: S, sample standard deviation, sigma, population standard deviation. So for this example, to find the standard deviation, we need the formula. This should be little s equals this for the sample. So let's see why this is the formula and how it works. So here we have our x's, right, our data values. We have 10 of them. The deviation, and then we're going to do the deviation square. So let's work on that. And keep in mind, notice that we have x minus x bar. So that's the deviation. Remember, the standard deviation we said is of a set of sample values is a measure of how much data values deviate away from the mean. So that's why we're doing this. So the deviation is how far are you from the mean. So we want to find all of those for our data values. So let's remind ourselves, what was our mean? We found our mean above, which we found it to be, where is it? Right here, 45.4. So this is our x bar. So we already found that. So let's put that in here. So x bar is 45.4. So that's the mean of these 10 values. So now let's find the deviation. So x minus x bar. So that means I'm going to do 44 minus x bar, which I know is 45.4. And so put that in your calculator. I guess we don't need a calculator for this. So this is negative 1.4. And then the same thing for this one, x minus x bar. So 50 minus 45.4. So what is that? And so we get 4.6. And then 38, right? My x, this is my x value, minus x bar. X bar is 45.4. And we get negative 7.4, and so on. Let's complete all of these. All right, now that we've completed all of these, if you didn't, pause your video and try to do it on your own, and then come back and make sure we got the same answers. Now, the standard deviation, right, what we want it to be is that it's a measure of how much data values deviate away from the mean. So in a way, kind of think of it as the standard deviation is the average deviation from the mean. But if I just found the average of this deviation, that wouldn't be very helpful because I have some negative numbers in here. And so my deviation is not going to be accurate. I want to see how far, so I want to measure a distance away from the mean. The negatives, right, like notice that the 44 in the deviation is negative 1.4. So this tells me that I am a distance of $1.4, right, away from the mean to the left. So I'm smaller. So 44 is less than the average, than the mean. Here, 50 minus 45.4, we get 4.6. So that means that 50 is above the mean. So the positive and the negative tells me we're below the mean. The positive tells us we're above the mean. But as I start adding them up and divide by 10, I'm not going to get a true average deviation because these negatives with the positives are going to sort of undo each other, and I don't want that. So what we're going to do, and as you can see in this formula, is I'm going to square the deviations. The sigma means we're going to add them up. So we're going to add up the squares of the deviations, but then I'm going to square root it. So why am I square rooting? What's happening here is that when I take the square root of something square, maybe let me not use x, trying to bring you to your algebra here. If I have the square root of b squared, what do I get? Some of you might say b, but I actually get plus or minus b, right? Or the absolute value of b from our algebra memory. So it's still a b, still the distance, but this allows me to get rid of those negatives. So I square them and then I take the square root. So it's a more precise way of kind of doing the absolute value, if you want to think of it that way. So let's square our deviations. So this is going to be negative 1.4 squared, 4.6 squared, and so on. Negative 7.4 squared. So what are these? So put those in your calculators and see what we get. So the first one is 1.96. Make sure you use parentheses. 21.16, and then negative 7.4 squared is 54.76. So go ahead and pause the video, fill in the rest of these, and then add them all up. The big sigma means you're going to sum, you want to find the sum of all of them. So go ahead and fill in the rest and then find the sum. And then unpause and we'll continue. Okay, now that we have it all filled in, there are our deviation squares, and here's the sum of the deviations. So our formula is the square root of the sum of the deviation squared, that's what we just found, divided by n minus 1. So let's go to our formula here. So our standard deviation then is going to be the square root of the sum of the deviation squared, that's the number we just found, 278.4 divided by n minus 1. N is 10, so 10 minus 1. So 278.4 divided by 10 minus 1 is 9. And so when we put this in our calculator, what do you get? So we're going to get 5.56, and we can round out to find 5.6. And our units are dollars. So this will be $5.6. So what that means is that on average, the bills at this restaurant on that one night that we picked, our sample night, they deviate from the mean by $5.6. And so that's how we find standard deviation. So some important properties of standard deviation are that, so standard deviation is a measure of how much data values deviate away from the mean. And so that's really important. not away from each other, but away from the mean. The value of the standard deviation is never negative, right? We're squaring the deviation and then taking the square root, so it's never negative. We're essentially doing, it's a fancy way of doing the absolute value. Larger values of the standard deviation indicate greater amounts of variation. So the bigger the standard deviation, the more your data varies. The smaller the standard deviation, the less variation there is, right? So like if this deviation would have been 1.25, that means that all the bills at that restaurant, they vary by $1.25 from the average, from the mean. So that will be like everything is really close, like pretty much everyone ordered the same thing, or this restaurant has a very limited menu that all the bills come out to about the same. So that's what that will mean. The standard deviation can increase dramatically with one or more outliers, right? If someone spent $72, that will dramatically increase our standard deviation. And then the units of standard deviation are the same as the units of original values, right? Notice that here the values are dollars. The difference is in dollars. Once I square it, I have dollars squared. But because we're taking the square root, I have the square root of dollars squared is back to dollars. So the units are the same. And the sample standard deviation is a bias estimator of the population standard deviation. So what this means is that it doesn't center around the value of the population standard deviation, and also pretty much that is always the sample standard deviation is always an underestimator. So what this means is that if I have the population standard deviation, so say women's height or men's height, right? I can take the census of the US population and find the population standard deviation. Now, if I start taking samples, so say I take samples of 200 women and measure their heights and find the standard deviation of all those samples that I take of 200 women from the US in different areas, my standard deviation is always going to be an underestimate of the population standard deviation. So that's what it means by it is a bias estimator. So my sample standard deviation is going to depend on my sample. And the variance, we're going to talk about the variance in a little bit. The variance is an unbiased estimator. So that one does center about the population variance. I'm going to break up my video. And so in the next video, we're going to talk about the range rule of thumb and the empirical chart.